All right, so I wanted to do a video to help clarify the week 4 assignment for building a model of a molecule before I get started. As always, I just want to stress how I've set up my Google Classroom, right? So office hours are here, 11 to 1, Monday to Thursday. Here's my email address. This is the best way to get in contact with me. It's hard for me to keep up with comments on Google Classroom. I want to keep comments open because other students will answer people's questions, which is very beneficial in the long run. But if you want to get a hold of me, this is your best bet. I have my phone with me and my laptop's not far away. So if you cannot make office hours, I will accommodate outside these hours. I just need a little bit of a heads up via email. I'm fine on Fridays. I'm fine Saturday. I'm fine on Sunday. I just want you guys to be able to access information. Um, Looking at work, keep in mind office hours has a topic devoted. So you have the link to my Google Meet, right? I have expectations, Q3 work, and then everything, each week's work assignment has a topic. Okay, so this is where you find information. All right, I just wanted to make sure that that's clear. So let's look at Q4, week 4. So for this assignment, I did an overview video, 2 videos. One talks about what I'm looking for, and then some examples. And as with any assignment, if you still have questions after reading the instructions and going through the materials, that's a good sign you should be in my office hours or contacting me to do some sort of one-on-one meet. If you're not comfortable, because office hours means there will be other students, we can do one-on-one. It's totally fine with me. All right, so let's dive into the assignment. And I'm assuming you've watched the materials. So if you're still confused, let's go back. So here are the learning targets. So here are the learning targets that we covered up till now. And so I just want you to be thinking about these things. And if you're reading through them and you're just like, I don't even know what this stuff means, you might want to review your assignment, ask some questions. I'm not looking for you to reproduce those targets, but those are just like checkpoints. The other thing you want to use, the last week's assignment was that poll goal to help you come up with your model that you're going to build for the assignment. And so the first thing you need to do is you need a molecule, right? And that molecule is either going to be composed of covalent bonds or ionic bonds. And we know that from class. And so you know how to identify the bond of the molecule based on where they are in the periodic table, right? So here's my periodic table. So if I have a metal and a nonmetal, it's going to be ionic. If I have a nonmetal and a nonmetal, right, these guys, then it's going to be covalent. Ionic bonds transfer electrons, covalent bonds share. Okay, so once you've decided on a molecule, then you want to determine the bond, right? And then, so there's 2 things to this project. The first thing is your actual model. And so in those videos, I showed you how I built from pipe cleaners and beads. I made a covalent molecule and then I made an ionic molecule. With the ionic molecule example I gave you, it was a group of ionic molecules, all the same, that come together, right? It was NaCl in that example. So how you do it is up to you. So let's go over to my blank sheet. Erase this. Oops, eraser. Okay. So the first thing you need is a molecule. If you're having trouble picking a molecule, then ask me for one. I can always figure one out. You can look back at your poll goal, right? There was a ton of them in that poll goal that you could choose from. So let's look at potassium chloride, for example. All right. I know, because I've been doing this a long time, potassium and chlorine have these symbols. Potassium, right, is right here, K. That's a metal. Chlorine's non-metal. Remember, hydrogen is just in this column. based on the number of valence electrons. It's a nonmetal. So anything you combine, like go hydrogen and a nonmetal, right? Remember, that's covalent. In this case, we got potassium and chlorine. Potassium is in the first column, which means it has one valence electron. Okay? So I'm going to do one of these guys. Chlorine, on the other hand, is a nonmetal, and it's in the 7th column, so it has 7 valence electrons. This was all quarter 3 material, so you should remember that. And remember, this is our dot structure. We should have up to 8 electrons. Okay. So we know metal, nonmetal is going to be ionic. So what happens with an ionic bond? The ionic bond, there's a transfer of electrons. Each atom forms an ion. Metals form cations. By definition, cations lose electrons. Nonmetals form anions. By definition, they gain electrons to become what? Stable. So potassium will transfer its electron. And that's what holds these guys together, right? Potassium has lost its valence electron. One less electron means it has more protons, which gives it this positive charge. Gaining electron means more electrons than protons, right? Because that's all the positive charge. So it becomes a negative charge. So we draw these brackets, right? There's the electron. Get rid of this. So now I've got my dot structure. If you look back in the POGL, this looks right. That's what's holding this together. Think of it as those electrostatic forces, right? It's this electron that has been transferred that's holding this one molecule together. All right, so if we go back to my sheet, I've identified it's an ionic bond. It's composed of a cation and an anion. We can talk also about the electronegativity. The octet rule specifically has to do with covalent, right? So in this case, I would talk about electronegativity, the cation, and the anion. So what about electronegativity? Remember, I have this other periodic table. This was back in week 2. That shows my electronegativity values. We know from class and last quarter, right, the trend of electronegativity is going to increase going from left to right on the periodic table. And these are the numerical values that have been assigned, right? Remember, electronegativity is the affinity of an atom for electrons. These guys want to be stable, like noble gases. So do these. They lose electrons to do it. These guys gain, right? So think of electronegativity as how much they want to gain an electron. Gaining an electron when you have 1 valence electrons doesn't help you, right? You're not going to gain 7. That doesn't make a lot of logical sense, but you could gain 1, you can gain 2 or 3. So when we look at electronegativity, if you remember back from week 2, if we take the difference between the atoms, chlorine, which has 3, and potassium, which has 0.8, you get 2.2. Any difference in electronegativity between the atoms that's 2 or greater means it's an ionic bond. So if you're filling in the sheet, right, you're going to talk about the fact that you have an ionic bond, a cation and an anion, what those definitions mean, and how you present it is up to you. Bullet points or paragraph is fine. And then you're going to talk about the electronegativity. You could talk about the overall trend of electronegativity and that ionic bonds tend to have a large variation in that. I'm not looking for a lot. I'm looking for concepts. Now, you need to pick something from the structure. Okay, what about the ionic bond? It's free-floating electrons, right? So you can talk about those properties. Talk about valence electrons. That's what's included in the Lewis dot structure. Where are they? The outermost electrons, right? They're in orbitals. Like these are all things you include. I'm not looking for much more than an understanding. Okay, so You can also talk about the chemical formula, right? And the ratios, and how in one molecule, right, I have one potassium and one chlorine atom. And that's the other thing. You have to make sure you include the chemical formula. Okay? That's a given because we learned about that on the POGL. Okay? So I am okay with you using this example and just filling in the blanks if that's what you want to do, but I want it to be accurate. Okay? If you're going to choose, and remember, you don't have to do all of these, just the ones that apply. Okay? So if you're going to do this one, you should be able to figure out the chemical formula. I shouldn't have to tell you. So that's a lot of work to get you started. If you wanted to do this with a covalent bond, I can include another video that shows you how to do that, okay? But this would be an example of an ionic. Again, if you're struggling with an assignment, please don't wait till the last minute, okay? All right. All right, so whoever got this video, remember, you probably got this because you had some questions but couldn't show up to office hours. You can also put them into emails as well. I'm always available for you guys. All right, thanks. I'll post another video on the other clarifying on how to do this.